Today we will be studying static electricity, which is chapter 18 of the Cambridge International Physics syllabus. First of all, we need to know the two types of charges, positive charges and negative charges. The SI unit of a charge is coulomb and can be written as capital C. And in formulas, it is represented by capital Q. So the first property of charges is that like charges repel each other. We can see that the positive charge is moving in the opposite direction from the other positive charge, showing the repulsion. The same can be said about like negative charges. The second property is that unlike charges attract. So this positive charge is moving towards the negative charge and vice versa, showing the attraction. The structure of a neutral atom is that it has the same number of protons, neutrons, and electrons. The positive charges of the protons cancel out the negative charges of the electrons, and the neutrons are neutral, so in its entirety, the atom is neutral. When an atom loses electrons, it has more protons than electrons, meaning that the atom has become positively charged. While when an atom gains electrons, it means that it has more electrons than protons, hence it's become negatively charged. So we can reach to the conclusion that it's the transfer of electrons from one atom to another atom that causes each atom to become charged. Next, we need to know the definition of insulators. Insulators are materials that have very few free electrons and hence do not allow the charges to flow through them. Common examples of insulators are wood, glass, plastic. Conductors are materials that have a large number of free electrons in them, which allow the charges to flow through them. Common examples are gold, copper, silver, basically most of your metals, and impure water. So the first process of charging is to charge by friction. We take a plastic rod and a cloth and we rub them together, which produces friction between the two. This friction causes each object to become charged. So the rod loses electrons, hence becoming positively charged, whereas the cloth gains electrons, becoming negatively charged. Next, we need to know the definition of induction and earthing. Induction is the process of charging an object without making any contact with the charging object. And earthing is to provide a conducting path for the flow of charges towards or away from the ground, and its symbol is this. We need to understand that when positive charges are earthed, electrons move from the ground to the object, and when negative charges are earthed, they move from the object to the ground. The second process of charging is to charge by induction. First of all, we take a metal sphere and place it on an insulating stand. We need an insulating stand so the charges can stay in the sphere and not be earthed. This will generate accuracy and success of the experiment. So in step 1, we bring a positively charged glass rod near the metal sphere. We will see that the charges separate in the sphere. Since like charges repel, the positive charges in the sphere are repelled by the positive charges in the rod and move far away from the rod, meaning they move to the right side of the sphere. Whereas opposite charges attract, so the negative charges in the sphere move towards the side of the sphere where the positively charged rod is the nearest. In step 2, we earthen the metal sphere. In this case, electrons flow from the ground to the metal sphere to neutralize the positive charges on the right side of the sphere. The negative charges, however, stay where they are. Step 3 is to remove the earth connection. And so we can see that only negative charges are left, which are still attracted to the positively charged rod. And step 4 is to finally remove the positively charged glass rod away from the sphere. This causes the attraction between the two to finish, so the negative charges in the sphere are distributed equally. To charge two metal spheres with equal and opposite charges, we have to take two metal spheres and place them on separated insulating stands. Step 1 is to bring a positively charged rod near the metal sphere A. You will see the charges will separate. Like charges in the sphere will repel those of the rod and move towards the end of sphere B. Opposite charges will attract, hence the negative charges in the sphere will move towards the side of sphere A where they are closest to the positively charged rod, as shown in the diagram. Step 2 is to is to that while keeping the positively charged in its position, separate the spheres A and B a little bit away from each other. And step 3 is to remove the positively charged rod entirely away from the experiment and separate the spheres far away from each other. We will notice that there are equal negative charges in sphere A and equal positive charges in sphere B. So the applications of electrostatics are firstly spray painting. In spray painting, the nozzle of a high-pressure spray gun is made to be negatively charged and the item to be painted is made positively charged. So when the paint drops touch the nozzle, they also become negatively charged and are attracted to the positively charged item. So they travel to the item and coat it, or in other words, paint it. This process is especially used in painting cars efficiently and for less money and time. The second application of electrostatics is the flue ash remover. In this, we attach a negatively charged wire gauze inside the chimney of a large-scale factory. So when ash, smoke, dust particles, etc. pass through the wire gauze, they also become negatively charged. And above the wire gauze, there are metal plates attached to the chimney walls, which are positively charged. So when the negatively charged smoke, ash, dust particles, etc. move towards the positively charged metal plates because the opposite charges attract each other. So thus, this prevents harmful emissions from entering the atmosphere. The disadvantages of electrostatics is commonly seen in lightning. So when different particles in the clouds collide with each other, it causes the cloud to become charged. In this case, the negatively charged particles are at the bottom of the surface of the cloud and the positive charges are on the top. This causes the positive charges on the ground to be on the top surface and the negative charges to be at the bottom surface as seen in the diagram. This relationship between the cloud and the ground causes the air to become ionized, and the ionization of air causes lightning to strike the ground, which is quite dangerous. An important note is that in exams, they can give you questions about these experiments, applications, and disadvantages, and which require the same concept, but sometimes they mix up the charges. So for example, they may not always make the bottom of the cloud to be negative, it can be positive. So it's your duty to conceptualize that if this bottom of the cloud is positive, then the top surface of the ground is to be negative and vice versa. So the question was specify at least one charge which will help you identify the other charges. Next, we need to know what an electric field is. It's the region around a charged body where an electrical force can be felt. An electric field is represented by the electric field lines. The direction of the electric field is the direction in which a point charge or a single charge can experience a force. The arrowhead on the field line gives the direction of the electric field, which is always from positive to negative. So the electric field pattern due to a point charge is that for a positive charge, the field lines move away from the charge, and for a negative charge, the field lines move towards the negative charge. The electric field between two unlike charges is that the lines move from positive to negative. And between two like charges, they are seen repelling from each other. They don't touch at any point and move in the opposite direction from each other. Keep in note that in any electric field pattern, the lines never touch. And when you are asked to label an electric field, make sure to never make your lines touch. The electric field pattern between two oppositely charged plates is that the electric field lines move from the positive plate to the negative plate. As you can see, the lines are all straight in tension. This is because if we take this line, the line to the left of it is emitting an equal and opposite force on this line, and the line to the right of it is also emitting an equal and opposite force on it. This straightens the line. However, we can see in the last line, it's curved. This is because to the left of it, there's a line that's emitting an equal and opposite force on it, but on the opposite side of this curve is that there's no line. So basically this line will curve out because there's no other opposite force to straighten it out. Next, we need to know what current is. Current is the rate of flow of charges, and its SI unit is amperes, and in formulas it is represented by Q. So the formula of current is equals to charges over time, or in short form, it's I is equals to Q over T, in which I is the current, Q is the charge, and T is for time, which is to be calculated in seconds. The charge of one electron is 1.6 times 10 raised to power 19 coulombs. This concept is important in static electricity because in exams, questions regarding this formula come up, and they're important to solve if you want to gain marks in all the static electricity questions. However, this will be more formally discussed in the next chapter, which is current electricity. So for now, this is the end of the topic, and I hope that you understood.